Okay, so we're going to be reviewing some factoring techniques that you should have seen in a previous math class before. But if you don't remember, we will go over them because you have to know how to do these factoring techniques if we're going to be doing any of the other polynomial stuff I'm going to teach you. So we need to know all the possible ways to factor because factoring helps us get to finding zeros, which finding zeros is the more important part. And sometimes it's helpful, you guys, to write polynomials in factored form. So we need to know how to factor the polynomial in order to write it in factored form. But anyway, so the first type of factoring we're going to talk about is a difference of two squares. So what this rule states is if you have two terms that are both perfect squares, which means you can square root both of them, and they are subtracting, that means you can use this rule. Okay, so we can only use this rule if you see two terms, first of all. They have to be subtracting, and both terms have to be perfect squares. And if you find that, when you square root each of these pieces, you add what you get after you square root, and then you subtract them, and then you're done. Now, something we need to keep in mind. Whenever you use any factoring technique, you must always factor out the GCF first. Always. Okay? So first, I'm going to be looking for a GCF. So I'm going to look at my numbers first. Is there a number that goes into 4 and 36? And I'm trying to think of the largest number that goes into 4 and 36. Holy hot dog, you guys are so smart. That would be 4. So I know my GCF part of it is a 4. Okay, now I need to look at the variables. So let's look at the m's. So we're trying to think about what's the largest amount of m's that I can grab out of each term. So if I were to grab the same amount of m's from each term, what is the largest amount I could pull from each? Holy hot dog, you guys are so smart. It would be 3 m's. Since this one has 3 m's and this one has 5 m's, the most I can grab is 3. And kind of the rule of thumb, you guys, you pick the one with the smaller exponent. So that would be m to the third. That does say third. Sorry. It says to the third. Alright guys, and since both terms don't contain an n, okay, we're going to leave the n's alone. So this is my GCF. So what we do, you guys, when we pull out the GCF, we write the GCF first, which I'm going to write it over here, 4m to the third. Okay, and then whatever we get after we're done, we put in the parenthesis, which the way we get what's left over, which I'm going to actually erase this and I'll explain why. Not that it's wrong. Okay, but when we pull out the GCF, what we actually end up doing is dividing each term. And I kind of ran out of space to divide. So this is our GCF. Okay, so after you determine the GCF, you divide both numbers by the GCF. So we have 4m to the third and divided by 4m to the third. Okay, and whatever's left over, we're going to write over here. So let's take it one piece at a time. I'm going to do the numbers first, then the variables. So 4 divided by 4 will cancel out and turn to 1. So bam, those cancel out, and it'll turn to just a 1. Okay, and now, m to the third divided by m to the third, well, guess what, you guys? Anything divided by itself is 1, so that will also cancel out. So my first term, I'm just left with 1 n to the fourth, which is the same as n to the fourth. Okay, now my second term, I have minus a 36, so a negative 36 divided by 4 will give me a negative 9. Alright, and m to the fifth divided by m to the third. Now, whenever you divide two variables that contain exponents, you must subtract the exponents. So 5 minus 3 will give me m squared. Okay, so I factored out my GCF and I divided each term by the GCF, and this is what is left over. Okay, so using this piece now, I'm only going to be looking at this, you guys. Only this. Okay, and with the parenthesis, I am going to factor this using a difference of two squares. Okay, so this is like my a squared term, and this is like my b squared term. Okay, so what we do, you guys, for a difference of two squares, you take the first term. Where we get the a in the formula is by square rooting the a squared. A squared, if you take the square root of a squared, you get a. Okay, so I'm going to square root my a term, which is this first term. So I'm going to square root the n to the fourth, or you can write 1 n to the fourth. It really doesn't matter. And then my c term, I'm going to square root the second term, but I'm not going to look at it. Sorry, this should be c. Good golly, Miss Long. This should be a c. not a B. Sorry, guys. Okay, I'm using this formula, so it's a C. Okay, so the C term is my second term right here, but when you do the C, you do not include the negative. It's minus C. Okay, so minus the C value. So we're only focusing on the C, so I'm going to ignore the negative when I do this. So the square root of 9m squared. Okay, you guys, so let's square root both of these. All right, now, whenever you're taking the square root of something, there's secretly a 2 as my index. Square root means I need two numbers that multiply to equal that value. Okay, so secretly there's a squared in the index, even though we don't put it there. Mathematicians are lazy. If they can leave stuff off, they will. Okay, but the index is secretly a 2. Now, if you have variables with exponents, the way you square root them is by dividing the index by 2. Okay, so we always divide our exponents by the index, which in this case is 2. Okay, so 4 divided by 2 will give me a squared. So this is going to end up being n squared. Okay, and in this piece, you guys, we're going to do it each piece at a time. The square root of 9, what times what gives me 9? Well, that is 3. And then again, to get the m value, you divide the exponent by the index, which is 2. So 2 divided by 2 will give me 1. So this will be m to the first, or you can just write it as m. Okay, you guys, and my final answer. Okay, we always start with the GCF, so do not forget about the GCF. Everyone always forgets about the GCF, and that's our bestie, and we cannot forget about our bestie. Okay, so my GCF is 4m to the third, so this is my answer. Okay, and in the parenthesis, what we do with our parenthesis after we square root each piece, this says we add the a and the c, which this is my a, and that's my c, here, a and c. So this is my a, and that's my c. All right, and then we subtract the a and c. So it will be n squared plus 3m and 1. So we add them one time and we subtract them one time. And then n squared minus 3m. And then we're done, you guys. We factored using the GCF rule and a difference of 2 squares. So this will be my final answer. Holy hot dog. Okay, so if you guys think you understood that, example 2 is pretty much the same as what I just did. So go ahead and pause the video and watch or fast forward to the end to see if you get it right, if you think you understand it. Alrighty, so if you're still watching, the first step we always use when we factor is the GCF. Okay, which sometimes we don't have a GCF, and that's fine. If we don't, we just don't have a number out in the front. Okay, so let's look at the numbers. Does anything go into 25 and 49? You guys are correct. Nothing does. Okay, so 25 and 49 don't have a GCF. And I don't have any variables in common. This one has C's and this one has D's. So I don't have something in common between both terms. So this one does not have a GCF. So no GCF in this one. GCF. Okay, so I'm going to go directly on to our difference of 2 squares, which that says, the rule says, if we have 2 terms that are perfect squares, we square root each piece, and then we add them and subtract them, and then we're done. All right, guys, so for our a value, I'm going to take the very first term, which is 25c to the 8th, and I'm going to square root that thing. Which, remember, you guys, even though we don't write it, there's secretly a 2 in the index, so be careful. All right, and then the c value, I'm going to square root the second term, which, remember, you ignore the negative when we do this. Okay, so we're going to do 49d to the 10th. And remember, there's secretly a 2 in here. Alright guys, let's do this thing. So, let's take it one step at a time. So my 25, the square root of 25, what times what gives me 25? Well, that's 5. And then you take the exponent and divide it by the index. So 8 divided by 2 is 4. So this would be c to the 4th. Okay, so that's our a value. And then our c value, the square root of 49 is 7. And then 10 divided by 2 is 5. So this would be d to the 5th. Alright guys, and then for our final answer, we add them and subtract them, and then we'll be done. So I'm going to add these two together, so we have 5c to the 4th plus 7d to the 5th. And then in one parenthesis, I subtract them. So 5c to the 4th minus 7d to the 5th. And that would be my final answer, you guys. We can factor this using a difference of 2 squares. Holy hot dog, you guys.